Hello, Advanced Lab. So this video is just it's really brief, just talking about the next homework assignment I have for you, which is to help you get familiar with LaTeX or LaTeX, which is a typesetting software that you're asked to use for this class for writing papers. It's kind of the standard for writing for basically formatting text and scientific work. And there's a lot of advantages to it, but there is a little bit of a learning curve when it comes to using it. So that's what this assignment is for. So rather than having you jump in to the deep end when you write your paper, I'm having you do this little assignment so you get used to it. So if you go to the Canvas part of the course, if you either go to assignments or modules, there's going to be a LaTeX homework. I say it both ways. I've heard it both ways. That's right here. We'll scroll down. There it is. Right here. And this will fill this out. So this actually is basically completion. If you follow the instructions, you should get it correct. There's no analysis or derivatives or any of that kind of stuff. So if you click on it, what it's going to ask you to do is going to ask you to go to Overleaf. So you're going to create an Overleaf account. I know there's a lot of software for this class. It's just kind of the way it is, being a skills-based course. And Overleaf is a online LaTeX editor, tech editor. There are downloaded versions of this. I use something called TexWorks, which I think works quite well. TexWorks. I use that on my computer. It's a little bit lighter weight, but sometimes it's going to have you're going to need to install packages and all that kind of stuff. It's similar to Python in that case. So Overleaf's a nice kind of online version that should have everything you need. So when you go in here, you create a new one. It's not going to have anything, so you're going to create a new project. Just start with the blank project. You don't need, I'm going to give you a template that you're going to use, so you don't need to use any of their stuff. And the project will just be like Advanced Lab Template. Click Create. It's going to give you a little tech file here, and I'm just going to ignore that for now. So what you're going to do, and I'm not sure how much of this you could be able to see, you're going to upload a file. You're going to upload the template I'm going to give you. So the template is going to be linked on Canvas there. I'm going to delete this little one they made for me that I don't need. All right, so right here, there's the template that we're going to be using. So if you look at the way that LaTeX looks like, is it kind of looks like code, and that's that's really how it works, right? It's almost like learning a new coding language. And so the best way to learn any kind of coding language is to have an example and then just work off of that. So that's why I give you this example. You're not going to have to change any of this formatting stuff at the top up here. This is all just going to be formatting that'll be standard. So you're not going to have to touch that. And then there's all the stuff, rest of this stuff is actually the code for creating the document. The nice thing about Overleaf and some other of the tech editors, TexWorks that I use also uses this. On the right-hand side is actually the PDF it generates. So what you do is you code on the left-hand side kind of the code in terms of creating the document. I'm going to stop saying code. It's not really code. It's not really coding. And on the right-hand side, it generates a PDF. You might ask, why don't you just use Word or a version of Microsoft Word? Because LaTeX is much better at formatting equations, formatting tables, inserting images, referencing the images, referencing equations, putting in citations, all that kind of good stuff. In physics, at least, the standard for putting together publications or that kind of thing is through LaTeX. Different fields vary on this, but I think it's a really good skill for anyone to learn. And so if you don't see it anywhere else in your undergraduate experience, at least you saw it here. Okay, so the way this works is the left-hand side is kind of the writing, the code, and the right-hand side is the PDF it generates. So you can see right now, it's trying to do. If I hit recompile up here on the top right, that green button, that actually makes the PDF what the left-hand side tells you to do. So you can see it's actually really nice and nicely formatted. This is in a 2-column style, which is kind of a standard for a journal. That's what I'm going to ask you guys to use. At the top here is a title. So if you look on the left-hand side, it says title, what you measured in fewest words, and then it shows up here, what you measured in fewest words. Then you have your author name, and then you have the affiliation, which wouldn't change, and then you have the abstract. So that's an aspect of the paper. We will talk about the paper next week when you write your first one. And then it goes section by section. You can see here, so you can actually put the day says date today, so I can actually do this to make it give me the date for the day, and it shows up exactly right here on the right, etc. So I'm not going to go through all the different parts of this. It's kind of up to you to parse what's going on the left-hand side to generate what's going on the right-hand side, but I'm going to point out a few things. One For example, you can do sections, and that's where it generates these section titles on the right, introduction, etc. You'll notice I put a little star after section. If I get rid of those, what it'll actually do is start numbering the sections, and we don't want to do that. So actually, if I took rid of the star, and I hit recompile, it'll take a second. You can see there it introduced a Roman numeral 1. That's not what we want. Papers and publications don't have those kind of sections. But if you wanted to do that, you can do that. The best way to learn any of this kind of stuff, like what do these things do on the left-hand side, is to Google it. For example, if I go down to one of the images down here, this one's in pink, you can see it's here, it says begin figure, and then it says HT. H means here, exclamation point is like trying to be like, definitely try to put it here. Because one thing you'll notice with LaTeX is that when you say put an image here, unlike Microsoft Word, which will put an image where you tell it to, but then it'll screw up all the other formatting, LaTeX will put the image close to where you tell it to, but it'll kind of put it in a way that makes the page kind of look as balanced and pretty as possible. In general, it won't put it like a bunch of figures in a row. It'll put figures on next pages and that kind of thing. And so sometimes it does what you, something better than you would have done, and sometimes it's a little bit worse. So you have to like play around with that. I'm not going to be grading you guys on whether or not the figures are in an ideal place. But what you will notice is that this is pink here, and on the right-hand side, there's just a white box that says boat.jpg. Because what this says is include graphics, then you tell it how wide it is. You can tell me how big to make the graphics, so you can rescale the images really well. And then it says boat.jpg. There is no boat.jpg in this folder, so it's similar to writing Python, where data files you reference have to be in the same folder as the Python file. So I have here the boat document, or the boat image. So I'm going to upload it. And then I'm going to hit recompile. And when I do that, boom, the boat shows up on the right, bottom right. So what you're going to, and so there's other things in this as well. There's a bibliothèque, or a citation at the bottom, which is really nice. I also give you coding for how to create lists. Lists are probably not going to be used a lot in the paper you write for this course, but these are just examples of how to do different stuff. There's a really nice table on the top right-hand side here. And on the left-hand side right here, right next to my picture, this is actually how you create a table. So you can see you put in these ampersand signs. It's actually how you separate the values. These little slashes indicate kind of how things work. You tell it how many columns to have. Actually up here is actually how you tell it how many slashes to have. So it says put two, on the very left, put two vertical lines, then have 3 vertical lines. So you can see that's what happens here. Then do 1 here, then do 2 here. That's how you make a table. Tables, I even say, I think I took it out of the caption, it was too big. Tables, you're probably not going to use a lot of them in the paper as well. Tables are really good for summaries of results, but don't make a table of your raw data. That's not what they're for. And the last thing, which is not the last, but one of the most important things you're going to be doing is equations. So here are 2 different equations. This is what makes LaTeX really kind of much better than something like Word. Did I already say WYSIWYG? Word is what you see is what you get, meaning you just type it and it shows up. But this is not a WYSIWYG. It's a very silly word. But it makes some really nice equations. So if you look on the right-hand side, it looks like an equation you might see in a textbook. And you might always have wondered, how do you actually create those? You don't create them by going into Microsoft equation editor in Word, although I do that sometimes. But if you had to do a bunch of equations, you're writing a theory paper or something, you would use LaTeX here. So you say begin equation here, then you write the equation. You can see the equation. There's certain things like if you use /pi, it'll show up as the pi, the Greek letter pi here. Same thing with eta. Underscore, it generates a subscript. The caret generates a superscript, etc. To get a fraction, you write fraction. Square root is square root. So it's kind of like as you might expect, but you're gonna have to look up what you need. So different equations will have different things. Like I don't have sines and cosines here. I don't have integral signs. So I would just go to Google and Google how to write integral sign in LaTeX or LaTeX math equations, that kind of thing, because it's the best way to learn is by learning how to do this is just by searching for it. You can also see the one nice thing here is it says label free fall and label radius. You're giving labels to the equations. So when you want to reference them later, you don't have to remember where you put it. You just say, oh, according to equation free fall, and then it would tell you that. That's exactly what happens here. It says where VG is the speed of the drop moving downward, equation reference free fall can be solved. So that what that lets you do is, if you're editing this, you can put another equation on top of it. You don't have to recount, oh, is this equation, used to be equation 1, but now it's equation 3. You can just reference the same thing. You don't have to edit this. So LaTeX is really powerful when you figure out how to use it. These dollar signs here, for example, help generate, it's called math type. So if you look on the right-hand side, it's italicized. But really, if you look at this template here that I'm going to give you, it has everything you need to generate your own version. So for this assignment, what you're going to have to do is just change some stuff about this template, and then it'll generate a new PDF, and then this button here, you'll download the PDF and upload it to Canvas, which is basically what you'll do when you write your paper. You'll write it in Overleaf and download it. Something to keep in mind, LaTeX doesn't do things like spell check. The nice thing is if you do this in web browser, the web browser will probably spell check for you, but if you downloaded TeXworks and you use like an offline version, it won't necessarily spell check, so you might have to write blocks of text in Word and then kind of paste them over or go back and forth like that. So the assignment here has actually what you're going to be doing with this. The assignment's going to ask you to change this equation. It's going to change you the image to like a cute picture of a cute animal, like, a pet you have or that kind of thing. Change your name, that kind of stuff. So just so you get familiar, modifying the tech kind of file, and then how do you generate new PDFs from that. If you get stuck on this kind of thing, this is a really good opportunity for you to post these questions in Slack, because that way we can kind of help. People will probably run into issues that are unforeseen just because this is, in some ways, again, it's like a coding language. But I think it's really valuable to learn, and I think everyone who comes out of a physics or even engineering physics program should learn how to use LaTeX while they're here. Okay, I hope that was helpful, and have fun with playing around with this.